Good afternoon. Today we will be covering section F7, factoring, splitting the middle term. But right now, I would like for you to go to the spiral review section in your composition book and work these three problems. Please hit pause and rejoin us when you are finished. Welcome back. So on our spiral review, if we look at the first function, this first function is not a polynomial because if we look right here at the 6x to the negative 2, 6x to the negative 2 really means that we are going to take and we are going to keep our 6 here in the numerator, and we're going to put x squared in the denominator. Therefore, it is not going to be a polynomial. Number 2, please compare answers. Your answer should be a trinomial. When we take a binomial and we square it, we have a binomial times a binomial, which in this case would give us a trinomial. You cannot just square the 3x and square the 1. You have to take 3x plus 1 times 3x plus 1. All right, and on problem number 3, the biggest error I see in students is they forget to distribute the negative to all the terms in the second polynomial. So just make sure that that negative goes to every single term in the second binomial. All right, if you will flip to the note cards in the front of your composition book, today we are factoring by splitting the middle term. Started. All right, you don't need to write this on your note card, but why really do we use splitting the middle term? Splitting the middle term is really just a process which often makes factoring easier when we are dealing with some larger numbers that are challenging to do in your head. And splitting the middle term is very procedural, so if you will learn the process and just do the same thing over and over and over, we use factoring for a lot of things in geometry, algebra 2, pre-calculus, and calculus, so factoring is just an integral skill, kind of like your multiplication tables. And then once we split the middle term, we are basically going to start the process we did last week with factoring by grouping, or we can factor using the greatest common factor box method, which I will show you today. Both of these methods result in the exact same thing. All right, our first problem. Actually, let's go through the process. So these are the steps that we are going to use when we split the middle term. If I go too fast, please feel free to hit pause at any time so you can write the steps on the front of your note card. So before we factor any polynomial, the very first thing we should always do is check for the greatest common factor. So when you look at a polynomial, first, check for the greatest common factor. When we want to split the middle term, so when we have a quadratic trinomial, we want to split the middle term, we're going to multiply a times c. And after we multiply a times c, we're going to find two factors of that number that add up to b. So the two factors have to add up to give us b. Then we will rewrite the polynomial, and we will either rewrite it from left to right, or we can always rewrite it in the box and basically undo the multiplication using the box method and take out the greatest common factor of each row and each column. So next up, we'll factor by grouping, or you'll factor using the box method. And then last but not least, you can check your work by multiplying the two polynomials you get together to see if you come up with the original problem. All right, so let's try what we can do. All right, we have the problem 12x squared minus 25x minus 7. So 12x squared minus 25x minus 7. So the first thing I'm going to do is I'm going to look at this quadratic trinomial, and I'm going to determine if there is a greatest common factor between 12, 25, and 7. Do not have a greatest common factor, so I'm going to the next step. So I'm going to multiply a times c. So when I multiply 12 times a negative 7, I get a negative 84. So step 3 said we want to factor, find two multiples of 84 which add up to b. So I'm kind of on a whole trial and error process right now. So when I look at 84, I know that 2 goes into 84 42 times, and I do know that one of them is going to have to be positive and one has to be negative. So if I just pick negative 2 plus 42 is going to give me 40, and I'm actually trying to get this number right here. I'm trying to get 25. So let me try something else. So 84, let's see if 3 goes into 84. 3 goes into 84 2 times, 24 left. So 3 goes into 84 28 times. I can make this negative, and if I do that, a negative 3 times 28 gives me a negative 84, but a negative 3 plus 28 gives me 25. Well, I'm actually trying to get a negative 25, so I can remedy this problem pretty easy. I can make this positive, and I can make this negative, and now my answer is negative 25. So if I take 3 times 28, I get negative 84 right here. But if I take if I take positive 3 minus 28, I get this 25, this negative 25 that I need in my problem. So those are the two numbers I'm going to be using. So here you have two choices, and I am going to do this both ways. So we can rewrite the polynomial by splitting the middle term. So instead of writing negative 25x, I'm going to start by writing 12x squared plus 3x minus 28x minus 7. Or we can use the GCF box method, which says, all right, I have 4 terms, so I need 4 squares in my box, and they're going to be 12x squared, 3x, negative 28x, and negative 7. Okay, so I'm going to teach you both processes today. It doesn't matter which one you use in the end. I'd pretty much pick one or the other and go from there. If you are going to split the middle term, right now you're going to start the same exact process we used last week. So right now I'm going to skip the split the middle term process, and I'm going to go to the box method. If I look at the box method, I am going to take one row at a time. So I'm going to look at this first row right here that has 12x squared in it and that has 3x in it. And I'm going to ask myself, do 12 and 3 have anything in common? Yep, they do. So 12 and 3 are both divisible by 3. There's an x squared and an x, so I can factor out an x. Now I'm going to take my second row. So I'm going to take this row right here, and I'm going to say, all right, look at my numbers. Do negative 28 and negative 7 have anything in common? I do believe they do, and so I'm going to take out, a minus 7, negative 7, and then an x and a constant, so there's nothing else in common. Now I'm going to look at my vertical rows. So now I'm going to look at this box and this box. So I'm looking at 12x squared and 28x. So I'm asking myself, what's the greatest factor between 12 and 28? So 12 and 28 both have a 4 in common. When I look at x squared and x, they both have an x in common. And then last but not least, I'm going to look at my last column, 3x and negative 7. 3 and negative 7 don't have anything in common, and x and a constant don't have anything in common, so I'm just going to GCF out a 1. This means that my two binomials are going to be 4x plus 1 and 3x minus 7. You can now check that to make sure we end up with my original polynomial. So we have 12x squared minus 28x plus 3x minus 7. I look at these two terms right here, and they can be combined. So now I have a 12x squared minus 25x minus 7, which if you come up and you look at the original problem right here, that is what I had in my original. So that tells me that I factored that correctly. If you want to do the grouping, I will go through that process very quickly. So if you group, our third term's negative, so I really want to write that as plus a minus. You will group the first two terms together. You will group the second two terms together. The GCF of the first group is 3x, which means you're going to divide a 3x out of here, and you're going to divide a 3x out of here. And if you do that, you're left with 4x. Because this right here is a binomial, you're going to have a binomial in your parentheses. 3x over 3x does not cancel out. It reduces to 1. Out of my second binomial, my first term is negative, so I'm going to factor out a negative. 28 and 7 both have a 7 in common, so I'm going to factor out a 7. And when I factor out a negative 7 out of both of these, here I am left with 4x, and a negative 7 divided by a negative 7 is a positive 1. Remember, at this point, underline term 1, underline term 2, and decide what they have in common. They each have a 4x plus 1 in common. So that tells me that I am able to factor out a 4x plus 1. And if I factor these 4x plus 1s out, they reduce to 1, and that leaves me with 3x minus 7, which ultimately is what I got when I factored using the box. At this point, I would pretty much choose, do you want to be at the box factorer or do you want to be the grouping factorer? Pick whichever method you like the best and then just roll with it from here on out. Try one more problem as a class, and then I'm going to give you a problem to try on your own. So splitting the middle term, we have 6x squared plus 7x minus 20. As always, step number 1 is checking for the greatest common factor. 6, positive 7, and negative 20 do not have a greatest common factor. So at this point, we're going to multiply a times c. So if I take 6 times negative 20, I get negative 120. Step 3 says we want two factors of a negative 120 that add up to negative 7. So this time I'm looking for something that adds up to negative 7. So I kind of think of 120, if I'm just going to pick the easiest thing for me, I'm going to pick 12 and 10. If I make one of them negative, that gives me a negative 2. So that doesn't work. So now I'm going to go, let's see, if I try 8. 8 goes into 12 one time with 40 left over. I get 8 times 15. It gives me 120. I need a positive 7. So if I make this one positive and I make my negative or my 8 negative, that's going to add up to a positive 7. All right, so step 4. Step 4 says we want to rewrite the polynomial. At this point, you're going to rewrite the polynomial and pick your method. Either group it or box factor it. So whichever one you prefer, go ahead and start that. I'll write it out like I'm going to group it first. So this is a 6x squared. This is called splitting the middle term. I do not care which comes first, the negative 8x or the 15x. But negative 8x plus 15x gives us negative 7x. So I am just really rewriting the polynomial, making it look a little bit different, but it has the same value. If you choose to do the box method, you would come put the 4 terms in a 2 by 2 box. So you would have 6x squared minus 8x plus 15x minus 20. All right, so at this point, pick your method. I'll go ahead and do the grouping method first this time and then follow it up with the box method. So grouping, my third term is already positive, so I'm going to group my first 2 terms. I'm going to group my second 2 terms. I look at 6 and 8, and 6 and 8 have a 2 in common, and x squared and x have a x in common, so I'm going to GCF out a 2x. 6 divided by 2 is 3. X squared divided by x is x. 8x over 2x reduces down to 4. Now if I look at 15x and 20, they both have a 5 in common. So I'm going to GCF out a 5, and I am left with 3x minus 4. Underline term 1, underline term 2. Determine if they have anything in common, and I do see that they have a 3x minus 4 in common. And when I reduce those down to 1, so both of those reduce down to 1, I can take out a 3x minus 4, that's the greatest common factor, and I am left with 2x plus 5. At this point, I want you to take a minute, and I want you to multiply those together and see if you get the original polynomial. For those of you on the box method, I'm going to take my first row, so 6 and negative 8, I can factor out a 2. X squared and x allows me to factor out an x. Then I'm going to take my second row, 15 and 20, I can factor out a 5. I do not have enough x's to factor out an x, so I'll just leave it as a 5. Then I'm going to take column 1. I have 6x squared and I have 15x. So if I look at 6 and I look at 15, I can factor 3 out of those. An x squared and an x, I can remove an x. If I come to the last column right here, I have an negative 8x and a negative 20. So I can factor out a negative 4. And when I rewrite this, it is going to be 3x minus 4 times 2x plus 5. If you check either one of those, you end up with 12x squared minus 8x plus 15x minus 20. And if we combine these two terms together, we get that 7x in the middle, and that will give me my original polynomial, 12x squared plus 7x minus 20. Problem is a problem for you to practice on your own. So at this point, hit pause and work this out on your own. And when you have it complete, turn your video back on and let's check and see if you got it right. All right, welcome back. I'm going to work through this pretty quickly. If I take 8 times negative 3, I get negative 24. I need a negative 10. So if I look at 24, 24 could be 6 times 4. But I need one of those to be negative, so that's going to give me a negative 2. I could use 3 times 8, and if one of those is negative, that's going to be 5, so that doesn't help. I could use 12 and 2. That's looking pretty good. I need a negative 10, so I'm going to make my 12 negative. So I'm going to use negative 12 and 2 when I split my middle term. Today, because we grouped last week, I'm going to use the box method for this particular problem. If you grouped, that's fine. Doesn't matter. You will get the same exact answer. So you have 8x squared minus 12x plus 2x minus 3. I take the GCF of my first row, so 8 and negative 12 have a 4 in common. X squared and x have an x in common. Row 2, 2x and negative 3 don't have anything in common, so I will GCF out a 1. Column 1, 8x squared and 2x. 8 and 2 have a 2 in common. X squared and x have an x in common. Negative 12 and negative 3, since this first term right here is negative, I need to factor out a negative, so I'll factor out a negative 3, and I can't factor out anything else, so this factors out to be 2x minus 3 times 4x plus 1. If I use the double distributive property to check this, I end up with 8x squared plus 2x minus 12x minus 3, which results in 8x squared minus 10x minus 3. And if you look, that matches the polynomial at the top, so we have done a great job. All right, if you have any questions, feel free to have them ready to ask in class tomorrow, and we will see you at the beginning of the hour. Have a good night.